All right, Unit 3. Let's start on page 171. We have two targets here. Define parallel lines, which the definition may not be what you think it is. It may be. And identify angle pairs formed by two lines and a transversal. So first, let's define parallel lines. And the definition is on page 171. Parallel lines are coplanar lines that do not intersect. I know that you knew parallel lines do not intersect. I don't know if you knew that they had to be in the same plane. Okay? And they do. They have to be in the same plane. So parallel lines are coplanar lines that do not intersect. Skew lines, that next definition down, are similar. They don't intersect either. But skew lines are lines that do not intersect and are not coplanar. Now, look at this figure here that we're going to look at in a minute to answer the 1, 2, and 3 from your assignment. But here's what we're talking about. See this line here, line YX, and this one, line SV? They are parallel lines. They're in the same plane. They're never going to intersect. No matter how long you draw them out, they're not going to intersect. But, look up here at the screen. See this line, TZ? It's not going to intersect either of those blue lines, is it? Ever. But we don't want to say that it's parallel to those blue ones, do we? That's not what we mean by parallel. We think of parallel as two lines that don't intersect, but you know, they're always the same distance apart from each other. They never get closer together. They never get further apart. So the red line and either of those blue lines would be an example of skew lines, S-K-E-W. They're never going to intersect, and let me get rid of one of them just so the red one and the blue one are skew lines. They're never going to intersect, but we don't want to call them parallel. So they made up a new term, skew. So parallel lines do not intersect. Skew lines do not intersect. The difference between them is parallel lines do not intersect, but they're in the same plane as each other. Skew lines do not intersect, and they're not in the same plane as each other. So, do we know the difference between parallel lines and skew lines? All right, we're in good shape then. And then parallel planes would be what you expect, are planes that do not intersect. Okay? Parallel lines, coplanar lines do not intersect. Skew lines, non-coplanar lines do not intersect. Parallel planes do not intersect. All right, so let's do some from our assignment. 1, 2, and 3 here are from page 173. It says, refer to the figure at the right to identify each of the following. Number 1, a plane parallel to plane ZWX. Now remember that to name a plane, you just need to pick out 3 non-collinear points in that plane. So plane ZWX is this flat surface up here on the top. That's plane ZWX. We're supposed to name a plane that is parallel to it. So what's the only plane drawn in this figure that's not going to intersect ZWX? Yeah, TSV or TUV or SUV or VU, right? Just pick out 3 of them. So it's that blue one there in the bottom. Y'all called it, oops, I need to write the word plane. Plane TSV. Perfect. Okay. Number 2, a segment skew to segment TS that contains point W. So look, let's identify where segment TS is. Now we need a line that's skew to it that goes through W. Should it be that one? No, those are actually coplanar, right? You'd have to slant the plane through there. Can you visualize the plane that would be slanted through there and contain both those? So it's not that one. What is it? That one, right? So, segment, oops, my V's and my U's look just alike. That's not good. W, W works. Oh, let's say WZ. Oops. WZ work as well? Yeah, I think so. Okay, so if you'd rather put segment WZ, I'm good with that. Okay, we good with 2? 3. All segments parallel to segment SV. So let's see, SV. All right, so name me a segment that's parallel to segment SV. Segment TU. They are definitely coplanar. They're not going to intersect. Name me another one. YX. Name me another one. ZW. Now on that one, you'd have to have a plane that's not actually drawn in the figure, but it would contain them both, wouldn't it? Is that it? That are segments that are drawn for us? Is that it? I think so. Okay. All right. Questions? All right, back to page 172, so back up just a bit. A line that intersects 2 or more coplanar lines at 2 different points is called a transversal. Any line that intersects 2 or more other lines is called a transversal. Now think about it. If you drew several lines on a piece of paper, they would all be coplanar because they're all on the same plane as the paper is. And aren't the odds pretty good that unless you purposefully made them parallel, they'd probably all end up being intersecting each other? So in effect, most lines can be a transversal, okay? Because you can draw any line that intersects 2 or more other lines as a transversal. So it's pretty common, isn't it? Okay? It's going to be common for a line to be a transversal. Now, in the diagram below, so this one right here on the right of the screen, line T is a transversal of lines Q and R. Here's line T, line Q, line R. So T does fit the definition. It intersects 2 or more lines. Okay? So T is the transversal. Now, by the way, if I drew Q and R longer, they'd intersect each other. Therefore, they would intersect 2 or more lines as well, wouldn't they? Okay, but in this figure, T is the one we want to call the transversal. So notice that T forms a total of 8 angles with lines Q and R. And then they number them there, 1 through 8. These angles and specific pairings of these angles are given special names. And you're going to have to know these special names. It's going to become more important in the next section than it even is today. Okay? So, everybody looking over here at this figure, and let's look at these definitions. All right? 4 interior angles line the region between Q and R. So the interior between lines Q and R, they have shaded green. So the interior angles would be the angles that are in the green shaded portion of the figure. So they would be angles 4, 3, 6, and 5 are the interior angles. Make sense? Well, if those are the interior angles, guess what you call the rest of them? Exterior. So 4 exterior angles line the 2 regions that are not between lines Q and R. So angles 1, 2, 7, and 8 are exterior angles. So interior angles are between your 2 lines. Exterior angles are on the outside of your 2 lines. Consecutive interior angles are interior angles that lie on the same side of the transversal. So look, angle 4 and angle 5 are interior angles on the same side of the transversal. So they are one pair of consecutive interior angles. Angle 3 and angle 6 are a separate pair of interior angles on the same side of the transversal. They form another pair of consecutive interior angles. Some books call them same side interior instead of consecutive interior. Same side interior is a little more descriptive, isn't it? They're on the same side of the transversal. Okay? Now, alternate. If you alternate between two positions, you go back and forth, don't you? Think of the words meaning about the same thing here. Alternate interior angles are non-adjacent interior angles that lie on opposite sides of the transversal. So, angle 4 and angle 6 are a pair of non-adjacent interior angles on opposite sides of the transversal. So they are one pair of alternate interior angles. What's the other pair of alternate interior angles? 3 and 5. Angle 3 and angle 5 are non-adjacent interior angles on opposite sides of the transversal. Well, alternate exterior angles work the same way, except we're talking about exterior angles. So they're non-adjacent exterior angles that lie on opposite sides of the transversal. So if angle 1 is one of our alternate exterior angles, which one pairs up with it? 2, 7, or 8? 7. Angle 1 and angle 7 are one pair of alternate exterior angles. What's the other pair of alternate exterior angles? Angle 2 and angle 8. Because each pair fits the definition, don't they? They're non-adjacent, they're exterior, they're on opposite sides of the transversal. All right? And then the last kind we have to identify for now, corresponding angles, lie on the same side of the transversal and on the same side of lines Q and R. So, I'll start with angle 1. It's to the left of the transversal, it's above line Q. So the angle that corresponds to it must be to the left of the transversal and above line R. So what angle is to the left of the transversal and above line R? 5. Notice that one of those angles is exterior, the other one is interior. All right, let's look at angle 2. It's to the right of the transversal and above line Q. Which angle is to the right of the transversal and above line R? 6. So that's a second pair of corresponding angles. Okay? Notice one's interior, one's exterior. What angle corresponds to angle 3? Angle 7. Because they're both to the right of the transversal, they're each below the line that helps form them. And then, it's fairly obvious, what's the only pair of corresponding angles we haven't named? Angle 4 and angle 8. Notice again, in each pair of corresponding angles, one of them is an interior angle, one of them is an exterior angle. Correspond, when you use the word correspond, it means that they match up. If two things are, you don't have to think about math for a minute. If two things are corresponding, they match up with each other, right? So you need to be thinking of angles that match up with each other, okay? So they're in the same position, all right? So, that's the way I look at it. If you just ask me out of the blue, okay, what angle corresponds to angle 2? I just look at it and I say, okay, it's to the right and it's above. So I find another angle that's to the right and above. And there it is. And there's a pair of corresponding angles. So you're looking for two angles that are in the same position relative to the lines in the figure. Make sense? Okay. Page 173 again. Classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior angles. Number 5. We have angle 1 and angle 8. So let's just go through the list. Are they alternate interior? No, they're not interior. Are they alternate exterior? Yes, they are exterior angles. They are on opposite sides of the transversal. They're non-adjacent. That's alternate exterior. Now we can abbreviate this. ALT for alternate, EXT for exterior, angle symbol, S. Alternate exterior angles. All right, number 6. Angle 2 and angle 4. What are they? They're corresponding. They're both above the transversal, and each one is to the right of its other line. So, corresponding angles. Number 7, angle 3 and angle 6. What are they? Alternate interior. They are definitely interior angles. They are non-adjacent. They're on opposite sides of the transversal. That is the definition of alternate interior angles. And number 8, angle 6 and angle 7. What are they? They're consecutive interior. They're on the same, they're interior angles on the same side of the transversal. That's what we call consecutive. You can do CONS, consecutive interior angles. Questions so far? All right, there are harder things in the world than identifying things, aren't there? All right, let's try these. Identify the transversal connecting each pair of angles, then classify the relationship between each pair of angles. Now, before we actually look at any of the problems, look at our figure. We've got 3 lines, M, N, and P. M intersects 2 other lines, so it's a transversal. N intersects 2 other lines, so it's a transversal. P intersects 2 other lines, so it's a transversal. So any of them could be the transversal, right? So let's look at each pair of angles they tell us to look at. Angle, for number 9, angle 2 and angle 4. Now, to identify the transversal, what I actually want to identify is what line is part of both angles. Now, we know the definition of angle is that it's made up of 2 rays, but rays are contained in lines. So which line, line M, line N, or line P, is part of both angles? N, because this ray right here is one side of angle 2, and then this ray right here is one side of angle 4. So line N is part of both angles. So that's the transversal. Line N is the transversal. So if that's the transversal then, now we have to identify angle 2 and angle 4 as being alternate interior, alternate exterior, corresponding, consecutive interior, whatever it is. What is it? It's corresponding. They're both to the left, kind of left and above the transversal, and then to the right. It's kind of getting hard to describe now that there's this figure, but they're corresponding because they're both to the left side, or to this side of the transversal, and then they're both on the same side of line P and line M. So they are corresponding angles. You with me on that? You see how to go about it? You see how, too, they can make any figure a little bit more difficult to identify the parts just by the way they draw the figure? All right, number 10. Angle 5 and angle 6. First, identify the transversal. What's the transversal? P. Line P is a part of each angle. And what kind are they? Yeah, they're alternate exterior. They're exterior. They're not between lines M and N, so they're exterior. They're non-adjacent. They're on opposite sides of the transversal, so they are alternate exterior angles. Go ahead and do 11. What's the transversal? N? M. Oh, I didn't hear you right, did I? Line M. And what are they? All right. Consecutive interior. Oops, I left off interior, didn't I? Consecutive interior angles. Questions? All right, go ahead with 12. And see if you got what I got. Everybody get line P for the transversal and alternate interior angles for the relationship? Any questions? All right, here's your assignment. Page 173 is where you start. Do 1 through 3, which we did. 5 through 12, which, hey, we did. 21 through 36, 51 through 54, and 59 through 63.